Hello, welcome back to Lorenzo and my space program, Planting Flags. The last episode, in episode 2, the mission failed horribly because the rocket snapped in half. Here, I've reinforced it with struts, basically the duct tape of any space program, and I'm going to launch. Now, before this, you might think I've did the second episode in which things indeed failed. No, you couldn't be more wrong. Before this, I recorded the whole episode you're watching now, a good 25 minutes, and everything went swimmingly. I left the episode at our transfer orbit into Minmus. Although I'm very happy I did pause because everything appeared to have crashed, so only the sound recorded and no video. So that's of course useless. What I'm going to do now, because I really don't want to do the whole maneuver planning again, even though I think I made a great tutorial out of it, is just show you the launch, the ascent, and then we're going to cut to where the mission is actually at, floating near Minmus. So the stages here are going to burn out, the first two stages, and oh shit, look at that, disaster strikes. One of the burning stages has detached. This did not happen in the first time, and needless to say, this is a problem. I do know what happened in the first one that has vanished into the oblivion of space computing. I throttled back a little bit. I did not do so here, which resulted in one of the boosters tearing itself free from the rocket, instantly unbalancing the rocket and causing it to plummet to its sudden doom. Now, we don't have time for this, so I'm going to restart the flight. This is a fake flight using only for videos. The actual flight is well and safe up in space. It's cruising toward Minmus. You can see it on the map here. This is the one I launched, so this here only serves to show you that launch and prove that my rocket is a capable one. Also, I want to tell you about SpaceX, which is my favorite company in all the world. So here we go, lifting off, throttling back. I'm going to throttle back when I reach 100 meters per second, just to reduce the stress on the rocket just a tiny bit, so it doesn't tear itself apart. This much should do it. Don't want to throttle back too far, because then we won't be able to ascend, obviously. So you might have noticed this is a night launch, because in the game I was playing that did not record. Of course, time has passed and the sun is now on the other side of Kerbin, or more accurately, Kerbin has of course rotated away. So going up and up and up, and these two first boosters, all the 5 engines, are now drawing fuel from only 2 tanks. These will of course drain very quickly, and when they are drained we will jettison them, causing the rest of the rocket to proceed unhindered by their dead weight. Now, what I wanted to tell you about SpaceX, it's a company that's it's a United States company. First, there we go, jettison the boosters and throttle back up. Ooh, look, it's jittering a bit. Oh no, not again, not again, not again. God damn it. I'm just going to reset it again and proceed with a lower amount of thrust. In retrospect, I'm feeling very happy that my first try with this rocket went so well. Apparently it's not very well designed after all. So there we go again. And what SpaceX does, it designs boosters, or stages rather, that can fly themselves back to the launch pad after they're spent. Of course, they will need some fuel for this, but they will autonomously land. They will not crash into the ocean, which will make them very expensive to recover. No, they will just land in the on the launch pad, on their tails, and will be basically, it's like a car. You can refuel them and they're ready to go again. Rapidly reusable launch vehicles, they're calling it. This will revolutionize space travel because it will make it so cheap. Fuel for a rocket, even though you need many gallons of it, is rather cheap compared to the rest of the rocket. The fuel for any given launch is about 8 to 10% of the launch cost. The rest of it comes in the expended hardware. Look, now they're jettisoning properly, falling back to Earth to crash. Now with the SpaceX booster system, they will actually land. They can be refueled and they will be ready to go again. These boosters are expensive, rocket engines are expensive, solid construction is expensive. So just dunking it into the ocean, fishing it out, and then completely refurbishing it is not the best way to do it, shockingly. Shockingly again, this rocket will not launch ever. I'm going to try it one more time, and after that you will have to take my word for it, because I want to plant the flag on Minmus, and I'm not going to put up with failing recording software, and I'm not going to try and play along to my recording, because I have the recording of my sound, of the voice, where I explain everything in a very patient manner, quite unlike I'm doing now, telling you about SpaceX and their wonderful boosters, reusable rocket systems and the like. I think the problem might be, apart from the not throttling back now, I'm pitching over too soon. This will cause air friction on the boosters, which will increase the stress beyond a tolerable level. So I'm going to try going straight up a little bit more. And yeah, if this isn't going to work, I'm just going to tell you what happened. And then we're going to cut to planting the flag, because after so much failures, I'm anxious for a success. And of course, as I cannot remind you often enough, the actual mission is in space, it has transferred to Minmus, and it's doing well. Ed Boss is the Kerman in there, Ed Boss, and he is happy, he is floating in his capsule, and he is not complaining. So, we can increase the throttle a little bit, we're not going fast enough, but we're going straight up at any rate. About the staging, we have five boosters. Well, we have a central stack and 4 boosters. Oh dear, they're wobbling so bad. It might have needed some more space duct tape. I'm just not going to steer very much. Just go up, go up, go up. So these 3 engines are now using the fuel from these 2 tanks. When these run out, they will be jettisoned as well, because of course empty tanks and rocket engines that are not firing are just dead weight. We don't want to spend any fuel getting them a centimeter higher than we have to. And we're just getting now through the atmosphere. We have a gauge here, the altitude gauge is at 15 kilometers, and here it says how thick the atmosphere is approximately. On the left is space, on the right is sea level. So we're getting through the thick parts, getting to the thinner parts. You notice the acceleration is picking up because of course thinner air has less resistance. Now as to the mission planning, this booster cluster will get us into orbit and a little bit on the way to Minmus. I did a lot of, I will show you the maneuver planning tool quickly when we're done, because I spent a good 10 minutes explaining it, which you will unfortunately not experience the second time around, because I cannot stand doing double work. This rocket ship is on the way to Minmus, you'll just have to take my word for it. So, going up, going up, going up, throttling down a little bit more, and starting to pitch over, because we are now at a reasonable altitude, almost in space, and the side boosters have run out. So jettisoning them, throttling up the smaller skipper engine to full power, pitching over the rocket, because now we're out of the atmosphere, now we can start to go sideways. The big boosters have been jettisoned, they will crash, and they are not going to be causing any structural instability. So, let's have a look at our map view. The apoapsis is 100 kilometers, and we need to boost this orbit to encircle the planet. This will happen, and to show you how, no, I'm just going to tell you what is going to happen afterwards. So this tank is going to run down. It will be about 5 minutes. Then we will have a blue circle around the planet here. And one of the great things is in this game you can use a maneuver planning node. Damn it, I hate that. I hate it so much that that video did not record, because it was a beautiful explanation of a beautiful system, and now you're going to have to make do with a horrid explanation of a still beautiful system. So you can click on the trajectory here, add a maneuver, and it will be a theoretical maneuver. You can say, let's see what happens if I add 2 kilometers of delta V here, and you see we get in orbit. After that, you can set a target for your trajectory. You can set Minmus as a target. You get all kinds of indicators where your planes will intersect, what you'll have to do. Well, it won't tell you what you have to do to get there, but it allows you to plan theoretical maneuvers. And using these theoretical maneuvers, you can plot an intersection. Now, I'm not going to be able to make it because we're still firing rockets. We are not even in orbit yet. But using this tool, you can make your theoretical maneuver go faster, go slower, go higher, go lower, go to the left, go to the right. You can tweak and tug and do it, and you will in the end get an intersect with, look, oh, did I accidentally get an intersect with something? That would be great, so then I can show you. Add the maneuver. This is rubbish. This is rubbish. I apologize for the rubbish. You deserve better, my poor subscribers. You deserve so much better than this rubbish. Anyway, please, please, please take my word for it. I'm going to see there's a lot of fuel left in the rocket. Take my word for it that this is the actual mission. I'm going to end this one here. You see the rocket can get into orbit. It can get into orbit if you do it very, very carefully. On the first try, I didn't do it carefully at all. It just magically happened in exactly the right way. And now I'm going to cut to the fun part of the video, which will be getting to Minmus. So disregard all my angry rambling about crashes. The rocket has launched, and in space we have been able to establish a maneuver node, and I will explain the maneuver node system more properly in the next video where we make it an intersect. Goodbye, and I'll be seeing you on Minmus.